Welcome back to Python scripting for GIS applications. This is a class at the University of Alaska Fairbanks, and it's spring semester 2013. Your assignment from last time was to create a date-time object. So we've got this Groundhog Day, and it is February 2nd, 2014. And what we want to do is write one line of Python code to tell us what day Groundhog's Day will be next year. So one way to do it would be to use the string format function, and then either a lowercase %a or an uppercase %a. So Groundhog's Day next year will be on Sunday. Okay, the assignment was to have a list of floods and then determine the number of years between this list of floods. So I'll make my list of floods. So I use the backslash as a continuation character here. So let's see what's in our list. So in our list, we've got these dates and times. So for example, we could loop through our list and then print out each object in the list. So what we want to do is calculate the difference between this date and the next date, and then calculate the difference between this date and the previous date. So what we could do is we'll make a list to contain these differences. So we'll initialize that. And then we'll loop through our dates. So we'll start at index 1. So we're going to start at this date. So then our list of differences will be the ith date minus the I-1 date. So if we're starting here, I-1 will be the previous date. Okay, so now we've got our differences between the two dates. So if we look at that list, those are time delta objects. So let's grab the first item on that list, and we'll just put it in a variable called test. So now test is that first time delta object. So then we could say, okay, test dot and give us days divided by 365. So basically it's 21.8 days between our first flood in 1967 and our next flood in 1989. So we can do this in a list. So we'll just loop through all the items in that list, and then we'll print out from our list of floods, and then we'll print out the number of years from our list of floods the next flood. And then we'll put a print statement in just as a blank line. So basically we had from 1967, August 1 to 1989, May 15th. The interval was 21.8 years. All the way down to July 6, 2006. And then the next flood was July 21, 2008. So that interval is 2.04 years. Okay, so in this video session, what I want to do is teach you how to grab shape properties using the field calculator. So here's an example. We've got some points and we've got a shape field. You could extract the x coordinate and the y coordinate if it's a point shape field. If it's a point z shape field, you could extract x, y, and z. And if it's a point M shape field where it has measures along some linear route system, you could extract the x, y, and m coordinates. So as an example, what we could do is calculate geometry and give us the x coordinate of a point. We could do the same thing using a field calculation in Python. So if we go to our field calculator, what you would do is make some function, and then we'll pass the shape field to this function. So our shape field, and in this case what we'll say is, okay, from that shape field get the first part. So dot get part 0. In this case they're not multi-part points, so it doesn't really matter, but you still have to do this. So get the first part, and that will be our point object, and then return from our point object the property x. So if you wanted to return y, you'd put a capital Y there. Here we're going to return x. Okay, needed to get rid of the space right here. And then just OK. So that is a field calculation that does basically the same thing when you right mouse click and calculate geometry. So the reason why I'm teaching you this with the field calculator is you can extract more properties using the field calculator compared to if you said calculate geometry. So for example, if you've got a point M shape, you can't get the M property from calculate geometry. Okay, so here's an example where we have a point on the Dalton Highway, and it's got an invisible property that is the miles in terms of how many miles up the Dalton Highway is that point. And if we right mouse click and say calculate geometry, it wouldn't allow us to do any calculation in terms of that. So calculate geometry will only give us the x coordinate or the y coordinate. So if we do use our field calculator, we'll be able to retrieve the true measured mile of that point. So what you would do is just say return point.m, and then we're just going to use our function, which I'll copy. So Control V, Control C for copy, Control V for paste. And then we'll pass the shape field into this function. And then just OK. So this point is on the Dalton Highway, and it's 76.7 miles up the Dalton Highway. Okay, here we have an example of a multi-part polygon layer. So basically we've got one polygon, but it's a bunch of parts, and it's balsam poplar stands along the Tanana River. So if we open the attribute table, there is only one polygon, and it's a multi-part polygon. So you might want to write a field calculator script that counts how many parts this polygon is composed of. So if we just load our script that I wrote previously, so basically we're going to pass the shape field to the script and then return the dot part count property of the shape field. So there are 24 stands that this multi-part polygon is composed of. Okay, here's an example where we've got lines as our shape field. And what we want to do is write a field calculator script that will give us how many points each line is composed of, or in other words, the number of vertices. So we could write that field calculator script. So in this case, these are single part lines, or not multi-part lines. So we simply initialize our count to 0, and then get our line, which would be part 0, and then we'll get the first point that line is composed of. And then we'll simply loop. So while we have a point, count is equal to count plus 1, and then get the next point. So we keep looping through until we end out of points, and then once we're done with this loop and we're out of points the line is composed of, then we return our count. So to use this, we'll copy our function. So Control C to copy and Control V to paste. And then we're going to pass the shape field to this function. just OK. So our first line is composed of 7 vertices. Our next line is a straight line. It's composed of 2 vertices. And then our third line is composed of 14 vertices. And our last line is composed of 10 vertices. So we'll highlight our second line and go zoom to selected features. So here's that second line that's composed of 2 vertices. Okay, and then you can also calculate the length of lines or the perimeters of polygons by just grabbing the shape field and then the length property and then ampersand and then whatever units you want. So here we'll calculate the length of each line in kilometers, and that would be the length of every line in kilometers. And we could change that to meters. So that's the length of every line in meters, and we could change that to miles, so US miles. And it would be the same thing if you have a polygon. You could calculate it. It would just be shape.area at, and then at acres or at hectares or at square kilometers. So for example, here I've got polygon shapes, and I created a double precision field, and I'll calculate the area of each polygon, so shape.area ampersand hectares. And the area in square kilometers. And the area in acres. Okay, so that concludes this week's video sessions on making field calculations. So if you go to the NRM 638 website, you'll have 6 field calculation problems to choose from, and you need to complete 3 of them